Right, that's time to start here. So I would like to start saying hello to everyone and welcome to today's section of the GLASE Webinar Series, a proposed horticultural lighting label. The GLASE Consortium Webinar Series is a selection of live recorded online presentations that cover a broad range of topics at varying technical levels and scale. These webinars feature the latest technology innovations and best practice in the CEA field, providing the audience the opportunity to discover new solutions and to connect with field experts. I would like to introduce today's presenters, Dr. A.J. Both from Rutgers University and Ryan Siddon from Intertek. Dr. A.J. Both is an engineer by training with degrees from Wageningen University in the Netherlands and Cornell University in New York. Dr. A.J. Both now serves on the faculty in the Department of Environmental Sciences at Rutgers University as a professor and extension specialist. His research focuses on methods and systems to provide the optimum growing environment in protected plant production facilities. Dr. A.J. Both is also the lead author on the paper Proposed Product Label for Electric Lamps Using Plant Sciences, which we will be presenting today. And we're to say that Dr. A.J. Both is also part of the GLASE Consortium as one of the academic PIs. On the other side, we have Ryan Siddon, which has been with Intertek Testing Services Lighting Division for 5 years, where he started immediately after receiving his bachelor degrees in mechanical engineer from Clarkson University in 2013. Ryan sits in Cortland, New York, at one of Intertek's lighting centers of excellence. Ryan has experience in and continues to work in multiple lighting groups and programs within Intertek, which include energy efficient lighting, horticultural lighting, airport lighting, automotive lighting, and traffic control lighting. I would like to say that a recorded version of this webinar will be available at our website, www.glase.org, within a few days or a few weeks after this presentation. If you have any questions about the presentation or if you'd like to get in contact with the speakers, please submit your inquiries using the chat box. I would ask everybody to keep your mics on mute. We have so far about 70 people join the webinar. So we'll do our best to answer all your questions at the end of the presentation. Now, with no further ado, I would like to pass the word to Dr. A.J. Both, who will start the presentation. AJ, do you have the mic and the control of the presentation? Please go ahead.
Thank you, Eric. I hope everybody can hear me. I'm very happy that you all joined the presentation today. I'm going to start off and I'm going to talk about the work we have done with a group of colleagues on developing a label for the horticultural lighting industry. Trying to get to the next slide. That doesn't seem to work. Let me see what I can do. There you go. Okay, I'm back to where I need to be. Here you see where we published the label in Hortechnology last year. You see the number of people involved in that article. If you have access to the label, please download it, or the paper, and please download it and read it. If you can't have access to it, please let me know and I'll be happy to send a copy to you electronically. As you can see, my collaborators on this paper were Dr. Bugbee, Kubota, Lopez, Mitchell, Runkel, and my co-worker here at Rutgers University, Claude Wallace. Most of those names will be very familiar to you, and it was truly a team effort to come up with the idea and to develop the ultimate version of the label that you see in front of you. The work was originally sponsored by a USDA grant that was a large specialty crop research initiative project that was headed by Dr. Kerry Mitchell at Purdue University. And that grant allowed us to purchase equipment that we can then use to measure various outputs and characteristics of individual luminaires. And that work resulted in this label idea. We quickly recognized that there wasn't anything independent out there that growers could use to evaluate lamps from different manufacturers. So we set out to come up with what we hope is a comprehensive yet not too complicated label that we hope will be used by the industry in the future to provide information to users about what a particular product produces in terms of output, in terms of electrical efficiency, et cetera, et cetera. So I'm going to go through several of the boxes here that you see on the label. I'm still having difficulty going to the next slide. I'm not sure why. Here we go. Why it's not progressing the way I wanted it to. So I'm going to talk to you about each of these individual boxes and explain to you what our thinking was, what our rationale was about each of those individual set of numbers that you see on those different parts of the label. I want to point out, looking at the red arrow on the lower left-hand bottom of the slide, is that we performed measurements as best as we could according to the Illuminating Engineering Society of North America standards that apply to a variety of lamps, including lamps that we use for horticultural applications. I think that's important for you to recognize. Although we are not a testing lab, a commercial testing lab, we don't have accreditation as a testing lab. We still have, as best as we could, followed the guidelines that were set out by the Illuminating Engineering Society related to measuring and evaluating lamps. So let's move on to the different areas. As I pointed out, the first area is pretty straightforward. It's a little box that shows you the brand name or the manufacturer name, the model number, and the lamp type. We picked a particular lamp, not because we like this lamp better than other lamps. It just so happened that this is one of the lamps that we tested in the past, and it was more or less randomly selected for display of the label that we published in the paper. So there's nothing special about the lamp. We don't particularly advocate for this lamp. It just happened to be a model we picked for display on the label. So I think this information is pretty straightforward, and I want to point out that our label is a proposal. It's not something that we demand. It's not something that we can tell the industry to use. We have no authority or no power over the industry to use this particular label. It is our idea, our suggestion to the industry of what we think needs to be included. And that means that the industry can adopt a different label, or they can add particular characteristics or numbers or measurements to the label, or they can display the label in a different form. That's all fine. We felt it was important to present the label as a first initiative to try to get the industry together and to try to adapt something that we feel is useful for users as well as for manufacturers who are trying to sell their products to the industry. So the next area on the label discusses the electrical components of the lamp. So you talk about input voltage, the current that is needed to run the lamp, and then the power consumption in watts that the lamp is consuming. So you need a fairly high-end digital multimeter to get an accurate measurement of these values, and that's what's presented on the label. So a grower knows what kind of voltage is needed to run the lamp, which of course is important when you think about running lines throughout the greenhouse or throughout the growing area. And of course, the power consumption is important because that's ultimately what's going to determine how much you're going to have to pay to operate the lamp. I mentioned in the text below the box that you could also consider adding the power factor, the difference in the shape of the waveform between the voltage and the current, because that's going to tell you a little bit about how efficient that lamp is, or how much power is wasted as you operate that lamp. We opted not to because we felt that was going a little bit too far. But if a manufacturer feels that that information is really important for that particular lamp, then they can certainly add that to the label. And then there's a note on the bottom that says that we have discovered and we have taken measures to prevent this, but if you have fluctuations in your power supply, then you can see small fluctuations in your lamp output. So when you do these kind of measurements, you want to make sure that the power supply is very stable so that that doesn't influence the readings that you get and then use on your label. The third area on the label is really dealing with photobiology and what plant scientists use to determine how acceptable a particular light spectrum is for growing plants and perhaps growing them in different environments. So it's not something that I am as an engineer particularly know much about or have a deep interest in, but I know that my plant scientist colleagues are typically very interested in these numbers because they tell a grower or a researcher something about how useful a particular light source is for growing plants. So there's some information here about what those numbers mean. The phytochrome photostationary state, the PSS, or sometimes called the PPS number, is important, as well as the red to far red ratio. Perhaps that's the one that you're most familiar with. We use a spectroradiometer to measure these values, so you need to have a setup that can do that. You have to have the instrumentation that can do that. And then we have some spreadsheets that we use to convert the ranges of the spectrum that we measure into these particular values. So again, these are numbers that are very useful for photobiologists and plant scientists in order to determine how useful a particular spectrum is for growing plants. And I give you a reference on the bottom, the Sager paper that was preceded by a paper by Gardner and Gracefo in 1982. Both those papers are really the basis for the photostationary state number. And then the last note that I have on the bottom here is that you can define red light and far red light differently depending on your definition. We used a particular definition for red and far red light to calculate the number that you see in the box. And that's important because, again, if you use different definitions, then you can have a different number. So you need to know what the definition is in order to compare red to far red ratios for different light sources. The fourth area on the label, on the lower left-hand side of the label, shows you the photon flux density for specific wavebands. It shows you the actual number in micromoles per meter square per second, as well as the percentage of the total as measured over the 300 to 900 nanometer waveband. We had several arguments about how large or how small we should make the largest waveband that we want to evaluate. We settled on the 300 to 800 to 900. I know that there's other ideas and other thoughts about stretching that waveband only from 300 to 800. So we picked a little bit larger range, but certainly if you wanted to, you could narrow that down to 300 to 800. I want to note that we picked wavebands in this table that do not overlap. So you go from 300 to 399 and then start with 400 and go to 499, etc., so that it's easier to calculate the true percentages of the total. But then if you do that, you can't quite get an accurate number for the PAR range because you missed the 700 nanometer number. So on the bottom of the table, you see the PAR range specifically identified. In this case, for this particular lamp, 183.6 micromoles per meter squared were measured for this lamp at a specific mounting height. And I want to stress and emphasize that we picked a particular mounting height to do these measurements, and therefore the calculation that you see in the table. There's really nothing special about the mounting height that we used. We found it was convenient for us. You can certainly use a different mounting height and then report the numbers for that particular mounting height. But I want to stress and emphasize that it is important that you do list the mounting height, because obviously as you move your sensor further away or closer to the light source, you will find different intensities and perhaps different ratios as well. The fifth area is the area that people probably will look at first. It's on the upper right-hand side of the label because it includes the total light output in micromoles per second. So this is integrated. This is a number that we determine by using an integrating sphere to measure this. And that can then be converted by using the power consumption of the lamp into an efficacy number, the micromoles per joule, which is the number that is widely used by the industry. Or if you want to use a number that perhaps a grower is more in tune with, you can convert it into a moles per kilowatt hour number, and then you need to use a conversion factor of 3.6. And finally, the last number that we included that we felt was important was a number that we hope will give some indication of how much of the electric energy that is consumed by the luminaire is actually converted into PAR. And then conversely, you can deduce from that number then how much of the electric energy is converted into non-PAR, which is going to be mostly heat. So this number will tell you something about how much heat a particular lamp produces based on the numbers that we measured in our system. The sixth area includes information that is not particularly useful for plant growth applications, but we felt it was important to include it because these numbers are used quite extensively for lamps that have human lighting applications, both in residential and commercial settings. So luminous flux, the colorated color temperature, and the color rendering index are numbers that are very common to report for lamps that are used for non-plant lighting applications. And so we felt it was important to include those. Again, they have no specific significance for plant applications, but it provides for a way to compare a lamp that was specifically designed for plant applications with other lamps that are specifically designed for human applications. The only exception perhaps to what I just said is the color rendering index, the number that you see on the bottom of the box. That's a number that tells us a little bit about how easy it is to determine the true colors relative to how you would observe the colors when a particular surface or an object was exposed to sunlight. So the color rendering index is typically set at a value of 100 when you put a surface or a particular object in a sunlit environment. That's our reference. And then depending on what a light source produces, we can redetermine the color rendering index, and numbers less than 100 will make it more and more difficult, depending on the size of the number, in terms of how easy it is to observe the true color. And of course, this is going to be important when you grow plants in an environment with a low color rendering index, because that typically means it's more difficult to observe the true color of, for example, a plant leaf. And when you know that plants exhibit all kinds of changes in colors, for example, when they experience nutritional deficits or nutritional issues, if the color rendering index is low, that typically means it's very hard, very difficult to distinguish those small color changes. And as a result, you need to know that so that you can select the light source that you feel is most appropriate for your application. On the upper right-hand side in this slide, you can see the setup that we used, our integrating sphere, for measuring several lamps that we have used to develop this label idea. The seventh area on the label is a case temperature, a temperature that is specifically of interest for LEDs and LED lamps. You see an example in the picture that is shown on the upper right-hand side of the slide. So it's not so applicable to high intensity discharge like high pressure sodium or metal halide lamps, but mostly for LED lamps. It's a measurement of the plate to which the LEDs are attached, because it is known that it's the temperature of that plate, that backing, if you will, that is typically attached to the heatsink. If that temperature of that location changes, then typically you'll get differences in light output. So the reason for adding that case temperature to the label is that it gives us a reference. It gives us the temperature that was measured during the measurements that are reported on the label. And so if somebody, for whatever reason, wanted to test a lamp at a different case temperature, then it's likely that they will find different light output. And so we felt it was important to keep everybody straight and to keep everybody honest, to include the case temperature, but that's again only useful for LED lamps, not so much for other light sources. The eighth area then provides you with a spectrum of the light output, and we again opted to show a spectrum starting at 300 nanometers and ranging all the way to 900 nanometers. So it goes past the far red region, which is typically identified between 700 and 800 nanometer, and it includes a little bit of the infrared radiation all the way up to 900. Again, you could pick a different range. As I mentioned earlier, 300 to 800 is often mentioned by people. We opted to go a little bit further and go all the way out to 900. I want to point out that this spectrum is a normalized spectrum. That means that we picked the highest output over that waveband range and divided all the other measurements by that highest value, so that the highest value in the normalized graph always ends up to be the value 1, and then everything is relative to that number 1. And we do that because it makes it easier to compare different spectra from different light sources. You treat all the spectra differently because obviously different lamps will produce different intensities and different shapes of the spectral output. And if you then normalize them, it becomes a fair comparison between light sources. So that's what we did. And you see in the insert a picture of how we do those measurements. We have a dark room, and we have a spectroradiometer that we place directly underneath the lamp, and then we take scans, and we average those scans, and then we calculate the normalized spectrum, as you see in the box, the label area number 8. The final area on the label is a distribution, or our attempt to show the distribution pattern of the light output from a particular lamp. So if you look at the insert, the little box on the left-hand side, you have to imagine that the lamp is positioned on top of the vertical axis at the origin, so at the 0 centimeters distance. And then you move away from that origin on a horizontal plane. Again, it's important to realize that we use a particular mounting height, in this case 2 feet. So if you start 2 feet below, directly below the center of the lamp, and you move away from the center of that lamp, and you continue to take measurements, you get something like that line that we show in this particular graph. Now, the very colorful pictures on the upper right-hand corner of the slide show you the actual measurements that we performed and the conversion of those measurements in this particular plot. So what you see is a bunch of radii. We take measurements in steps of 30 degrees, starting at the origin and then moving to the outside of the circle. And for this lamp, you can see that the distribution pattern is very irregular. So it doesn't really matter in which direction you look, you can see the same shape. And that's why for this particular lamp, we collapsed all those measurements into a single line that you can see in the image on the left-hand side. So that's only applicable for this particular lamp, which had a very uniform distribution of the light depending in which direction you went from the origin. Now, obviously, there are other lamps with different reflectors and different designs that may not be so uniform. And then you may have to add additional lines in this image to show distribution in different directions, in different angles that you went from the origin to take your measurements. Or you can do something as I show in the bottom picture here. You can use a polar plot to identify different intensities at different beam angles as you do your measurements. So there's different ways of representing the part distribution. We picked one way, but it's certainly not the only way, and manufacturers are certainly welcome to use whatever they feel is important. But we felt it was important that it's somehow represented on the label what the intensity distribution is going to be from a particular lamp. We can use that information then to help us design arrays of lamps, for example, in a greenhouse or in a growth area, to try to maximize the uniformity of the light distribution for a particular crop. Okay, I think that's where my part of the presentation ends. I want to thank you for your attention. And as Eriko said, please wait with your questions till the very end. And my last comment is, if we don't get to your question, feel free to contact me by email, and I'd be happy to try to answer your question one-on-one. Thank you very much.
Thanks, AJ. Ryan, are you able to pick up the screen?
Yep.
Excellent.
Okay. All right. Hello, everyone. Happy Friday. So as Eriko mentioned, I'm with Intertek Testing Services, and here's my presentation on the proposed horticultural lighting label. So just a little bit about us first. Here's a brief timeline that I put together for you guys. So the history of Intertek dates back to the late 1800s, especially with one guy in particular. And from my previous slide, I guess you can guess who that was. It's Thomas Edison. His dedication to bringing a reliable and efficient product to market provided the path for quality product testing for the next 120 years. To this very day, Intertek still uses the ETL mark as proof that your product meets applicable published standards. If you go to my third bullet right there, in 1896, Thomas Edison establishes the Lamp Testing Bureau of his Edison Electric Illuminating Company. It was later renamed ETL. So I guess you can say that we've been testing light bulbs ever since they were invented. And down in the right-hand corner, you can actually see our ETL logo. So our team, Intertek, is an industry leader with more than 43,000 employees in 1,000 locations in over 100 countries. I am located in Cortland, New York, in our lighting lab. We are a lighting center of excellence. The primary group that I do work for is our energy efficient lighting group, and we have taken in horticultural lighting metrics and performance. Our group consists of around 15 members, and that includes engineers, technicians, and managers. And in those 15 members, we have a dedicated team with a strong focus in horticultural lighting and technology. If there's something that we want you to remember us by, it's total quality assured. It's our Intertek motto. So let's get into the proposed label by GLASE that Dr. Both was just talking about. So here it is again over on the left, the label with the 9 components that was in the last presentation. So Intertek has the capability to supply official test reports with the data of the 9 lighting label components of their metrics. Intertek Cortland is a GLASE industry member, and we're also a GLASE partner. After I'm done speaking, I'm going to have Erica get into that for you guys just a little bit. So here is the testing for the proposed label. Here are the 9 components again, the wavelengths at which we are going to be measuring at, and the standard IES LM79. Quick note at the bottom, LM79 is applicable for solid state lighting devices. If you did have a different type of lighting source, I mean, you'd have to use that LM standard. We should also mention and remember that this is a test method and not a standard with requirements. And over on the right, you can see the different testing equipment. Power analyzers, spectroradiometers, integrating spheres, and thermocouples. So we'll get into our radiance measurements. You can see into the left, just a little example is a grid of power intensity in U moles per meter squared per second. This is also, we decided to put it at 2 feet to just show you guys. So this would be done using a spectroradiometer and a grid system in a dark room. You saw a picture from Dr. Bo's presentation. The same testing method can be used for components 3, 4, 8, and 9 of the lighting label, but you would just calculate the different metrics that you need with those units from this data, from the irradiance data. The input optics that we use are cosine corrected. As of right now, there's no standard grid size or pattern. Is the testing procedure committee going to follow up on this? The mounting height and grid width and intervals, or the horizontal angles if you're doing a polar plot, would depend on the product optics. So if you have a more quadrilateral type distribution, you can do as Dr. Bo said, just get one of the angles. If you have more of a linear throw, you might want to pick up both at 0 and 90. Manufacturers would be able to choose their own mounting heights and grid widths, or Intertek and GLASE can recommend these parameters after we review your product. It is definitely critical, as Dr. Bo said, that the statement of the mounting height is mentioned. So some sphere measurements. Over to the left, you see one of our integrating sphere stations. The same testing method can be used for components 5 and 6, the proposed label, and calculate the metrics where needed. Intertek Cortland has a variety of integrating spheres and spectroradiometers. We are a NavLab accredited lab. We have 3 meter spheres, 2 meter spheres, 1 meter spheres. We have some thermally controlled spheres that go up to 75 degrees Celsius. And we have spectroradiometers that include a range of 200 nanometers to 5,500 nanometers. So getting away from the label a little bit, some programs and standards, just briefly. So ASABE, the American Society of Agriculture and Biological Engineers. Right now what we're dealing with is 3 documents by them. There is S640, which was published in July 2017. This is more of the definitions and metrics of horticultural lighting. Your photon flux, radiant flux, photon flux density, etc. There's quite a few in there. You can actually get this document on the ASABE website, and it'll give you the ranges such as PAR, 400 to 700 nanometers, your UV, and your far red. The next one, which is still in development, and this is not the official name since it is still in development. These are, it's X642. These are more of the test methods, how you're going to get the irradiance measurements, your photon intensity, your flux measurements, photon radiance flux. And it mentions some equipment that you'd be using, such as a gonio spectroradiometer, integrating sphere with spectrometer, spectroradiometer by itself. And then the third one, also in development, performance measures of lighting system for plants. Also unknown if this name is going to change since it's in development, but this is more of like the recommended criteria for recording, more or less a specification. So let's get into Design Light Consortium, DLC. I am sure that you guys are very familiar with that. Before we start here, I just want to let everyone know and remember that this is all in draft form by DLC. Nothing is finalized. A few dates up the top here for you. In April, the first draft was distributed. Comments were due in May, end of May. In August, the second draft was distributed, and the comments were due on August 22nd. And then they say that in October 2018, the final policy will be released. The link below is very good for you guys to look at. It's documented well, what's going to come about. It explains everything very nicely. If you can take a look at that, and we'll get into the next slide where you can actually find some of this information at the site. So not a ton is changing. There are a few key items that are different from general illumination type applications and products. Integrating sphere testing, it's all the same. It's just what metrics are you using those radiant flux measurements to calculate for horticultural applications. So testing's not really any different. One thing that is going to be different are your IES files. It's going to be done using a TM33 calculator, which is pending right now. This is so you can get the photosynthetic photon intensity distribution in UMol per second per steradian. So unlike how you do with the GLASE label in a grid or a polar plot with only using spectroradiometer, you'd actually use something like a gonio spectroradiometer. To the left, you can see a picture of our Type C goniometer that is in Cortland, New York. Something else that is fairly different is the flux maintenance in situ temperature measurement tests, also known as ISTMT. They're moving from L70 to Q90. The Q is more of a general engineering term, quanta, instead of the L, which is more for general illumination type metrics such as lumens. You get these L70 or Q90 results from a TM21 or TM28 calculator, depending on if you're doing an option 1 or option 2 life test. So it's going to be a lifetime hours of 36,000 or greater, and this is actually going to be with the PPF data in the 400 to 700 nanometer range. As of right now on the website, they say that nothing is required for the 700, 800 nanometer range. It only has to be recorded. DLC has a few dates in there based on the new LM80s that are going to come out and when you need to use the new set of data with PPF data in it instead of the old luminous flux data. So I would check that out. It's a good read on there. And then the in situ testing must be conducted at the maximum environmental temperature on the fixture specification sheet. Also has to go along with safety testing, whatever temperature that was done at. And these measurements also have to be done for each LED type. Horticultural lighting, say you have red, blue, white LED packages, you need to have this test done on all of them, not just the hottest LED in the system. Another pretty big change is the safety certification, and we will get into that in a slide or two. Let's move on. So test plans, get into that a little bit. One of my favorite things to do. We can make test plans for any DLC application they have, not only horticultural, but photometric properties as well. But since we're talking about horticultural today, we can do that for you. So we want to do the least amount of testing possible for you at the most economical price. So things that we want to have up front from you guys, the product spec sheet, all the different types of configurations, optics, if it is a white light, your color temperatures in CRI, any type of drivers that are being different, that would go in the component spec sheets. So we want to know what your driver models are, your LED models are. Some other information we might ask for, depending on how large your product family is, are the LED make and models and driver for each lumen package. I guess you would say lumen package, but any light package, I guess, in this case, or photon flux package. And maybe the driver output current and the strings on those boards. We want to use this for more engineering judgment, less testing and more scaling if you can, depending on how modular your systems are together. So, I mean, basically, the more we know about your product up front, the easier it will be to list on that QPL. Intertek is an approved DLC testing laboratory. And if you would like, we can complete your application for you and submit to DLC on your behalf as a third party. Get into safety just a little bit. Definition for you. Horticultural luminaires are any luminaires that are identified in any way as a horticultural or a grow light and intended for growing flowers, vegetables, or any other type of plants. So the standards for testing are UL 5098 and supplemental 8750 for your LED type luminaires, UL 153 and UL 2108. And obviously which one you have to test to depends on your product type. These are the same standards for your general illumination type fixtures. Then we're moving into IEC 62471. This is the photobiological safety assessment, and this is going to be done from the wavelength ranges of 280 to 1400 nanometers. And then there's the UL subject 8800. This is getting more into the horticultural lighting requirements. So you're going to do all three of these. And then through Intertek, we actually have some additional safety tests since we have our own horticultural lighting certification program. So in addition to those three, here are a few more tests that you're gonna have to do. Elevated ambient temperature tests, you're done at a minimum of 40 C unless a specific temperature is specified by the client, in which case the product will be marked suitable for operation ambient, not exceeding blank degrees C, whatever it is. There's a corrosion test for outside type luminaires and non-fresh water. There's also elevated humidity tests. You can see below, depending on what the fixture is, what clauses of UL 5098, 153, or 962 you would have to test to. There is IP testing. To UL 5098, both rain and sprinkler tests need to be done. And additionally, your luminaire can comply with an IP rating of 54 or higher from IEC 60598-1. There are also some UV protection tests that will need to be done depending on what you're using in your product. Polymeric enclosure, polymeric material for a water shield, or if you're using some sort of gasket material that's relied upon to comply with ingress or corrosion protection. Quick note for Intertek, if the product is not tested to IEC 62471, the photobiological testing, you're going to result in having a recognition and not an ETL listing. Two types of horticultural luminaires for safety ratings. You can have an intracanopy luminaire, which is located within the foliage of the plant and vegetation, and non-intracanopy, which is located so that the luminaire does not contact the plant or vegetation. So unless specifically marked not for intracanopy use, all the horticultural luminaires doing safety testing shall comply with both the rain and sprinkler tests of class 13.4.8 of UL 5098 that you saw right here on the top. So that's all I have for you today. Here's my contact information. Any questions you might have, send them to my email. I'm pretty fast responding. That's me at the bottom. If you see me, I'll be at the Horticultural Lighting Conference in Portland, Oregon on October 9th. So if you see me, come say hello. And there's also a future GLASE event that's going to be happening. I'm sure Eric will talk about it. And if you see me there, come say hi. A few additional contacts for people I work with at Intertek. My department manager, Jeff Davis, he's a good guy to email or contact if you have any questions on horticultural lighting. Same with David Ellis. He's a senior project engineer in Portland, New York. I work closely with him for horticultural lighting. The safety engineering team lead is Matthew Parsons. If you have any safety related type questions, I'm going to ask that you email him directly instead of through this webinar. He's going to be able to better answer those for you. And then there's Andrew Hyatt. He's our national sales executive. If you don't have an account manager already, you can email him or call him, and he can get you set up, talk about quoting prices and whatnot. And that's all.
All right. Thanks, Ryan. Fantastic. Thanks, Ryan. Thanks, AJ. I will unmute AJ here as well. So AJ, you're live. Ryan, you can keep with our mic on mute as well. I would like to thank both of you. Great presentation. Just before I go any further here, I'd like to ask everybody that signed up for the webinar, if you have any questions, please use the chat box. There's a chat box. You can send a message, and I'll be reading the questions to Ryan and AJ as I receive them. In the meantime, I would like to just complement a few things here. So first of all, say how GLASE is supporting all that. I think GLASE is a public-private consortium that is designed to develop, transfer, and implement new energy-efficient technologies that can help CEA growers to make their systems more profitable and more efficient, and also help lighting manufacturers to design better systems that can solve real problems growers have today. And how can we accelerate this adoption? So I think this presentation today was a perfect example of this margin. GLASE is endorsing the lighting label proposed by AJ Both and his team that we just saw here today, because we believe the lighting label will provide growers a fair basis for comparison. Like AJ said at the beginning, that was the initial proposed label. It might change in the future as we get feedback from the industry and as we know how it is adopted. But for now, it can provide growers a very good source for comparison. It is not our role to say one light's better than the other, but then the growers can come to this conclusion if we can educate them on how to compare these different lighting systems based on the set of metrics, standard metrics presented by AJ and his team, which are relevant for horticultural applications. The next step is this partnership with Intertek. So we recently formalized the partnership between GLASE and Intertek. We're really excited with that, so we can now offer our GLASE industry members one complementary lighting analysis, which will provide to the lighting manufacturers the results on the format of the lighting label. So pretty much, if a GLASE member submit one lighting fixture to us, we can send to Intertek and we can get these analyzed for free for the lighting company, providing them the results on the lighting label. Another thing is worth mentioning is that the company will also receive the raw data files from Intertek. So then these raw data files can then be used to submit or apply for the DLC standards when they are released. We'll not cover all their standards, but there's several tests that can be used, so you can pretty much double dip. You can get double benefits out of that. And one more step would be providing any GLASE member with 10% discount to work with Intertek. So if a GLASE member wants to do something else with Intertek besides this complementary analysis, they would have 10% discount. Perfect. So we have here the first question coming is slide deck or on-demand version of the webinar? I was late to connect. So someone was late to connect. Yes, we will have this slide deck available at the website www.glase.org. So it is coming up after this presentation. Please give me a few days. I can work with our website folks and upload these presentations to the website. Let me see here. Second question coming here. What is the reasoning for putting the case temperature on the label rather than using a standard test ambient? It would seem to me this would be difficult to access in the end application for the user and potentially misleading. They might interpret a higher case temperature measurement as a luminary tested to a higher standard rather than one worse at dissipating heat with a higher output degradation over time. AJ, Ryan, you want to take a shot on this question?
Yeah, this is AJ. Can you hear me?
Yes, we can.
I think officially you are supposed to control the temperature in the room or in the integrating sphere or in whatever test rig you're using so that you can stay within a very narrow temperature range before you do your measurements. Now that in reality, in the practice, that turns out to be rather challenging. You would have to have a air-conditioned room, and especially when you think about a lamp that produces a lot of heat, that needs to be removed quickly so that you can maintain the temperature during your test at the required range, that became complicated. So we decided to go with the next best solution, in our opinion, which is to report the temperature, the actual temperature, after the lamp came to some steady state. So we run the lamps typically for an hour or more to get to a steady state output. And we check that before we do our measurements by looking at temperature changes. And then we report the temperature while we are doing the measurements. So it could be, you could decide to set your environment at a particular temperature and use that temperature then to do your measurements. In reality, we felt that was a very complex and complicated solution. For example, some testing lamps use an integrating sphere that is cooled so that they can maintain the temperature that are required by the standard that they use to do their measurements. Now, as you can imagine, cooling a large integrating sphere and keeping it at a very narrow temperature range when you have a pretty warm or heat-producing lamp inside is not an easy thing to do. So you're right that there may be some complications there. That may not be the accepted or approved method of reporting the temperature. As I said in my presentation, we feel it's really important that we do record at least some temperature that we recorded during our measurements, because otherwise a manufacturer could artificially change the temperature and report something that is in their favor. We felt it is important to report the temperature so you can independently verify the output at the particular temperature that we tested at.
Excellent. Thanks, AJ. Next question here, a very quick one. That would be for Ryan. Ryan, is there any representative of Intertek in Mexico?
You're going to want to contact Andrew Hyatt on this one. If there is one, he'll set you up with them. If not, he'll give you the best next answer on that. Perfect.
So I can make sure I share this contact later on. Let's go to the next question. For the spectrum reading, why are we using PPFD instead of PPF? It would be better for end user to use a sphere measurement with IES file for distribution. Anyone on that?
I didn't catch it all. Could you repeat the question, please?
Sure. The question is, for the spectrum reading, why are we using PPFD instead of PPF?
I think we use the PPFD because that's the accepted definition that we use in the industry. So I think I'll leave my answer at that. That's the accepted unit that we use in the industry for reporting the amount of light available for photosynthesis.
Perfect. Thanks, AJ. All right. We don't have any questions at the time. Oh, let me see. Yeah, for now we don't have any other questions. One comment I would like to make is that, so we got this question before, right, with the thermal management here, talking about the case temperature. I've been having a few conversations with lighting manufacturers, and they all have this concern on the thermal management. I think AJ gave good reasons here why measurements are done as they are now, but I think this could be one good topic of conversation for the future. There are many different types of cooling systems. LEDs can be operating at 100% or can be a fraction of the total capacity. So I think this thermal management aspect is something worth for us to be talking a little bit more in the future. I will do a follow-up with people, or if people would like to send me suggestions for future webinars, please let me know. But that seems to be a hot topic, no pun intended here, but the thermal management is something that keeps coming up all the time. Another question coming here. What about testing tunable sources? AJ, Ryan, would you have any step on that, on testing tunable sources of light?
Yeah, we do testing of tunable light sources, and of course that means that you have many more versions of the label, because you look at the output of lamps at, for example, only blue light or only red light, or a combination of red and blue light. Things become more complicated then. The lamp that I showed in the label is a lamp with a single spectrum. There's no way of tuning that spectrum. It's just turn the lamp on and you get the spectrum that it was designed for. But for tunable lamps, you get, of course, multiple types of outputs, and you would report then either a summary of the outputs, or you would have a whole set of labels identifying what the output is at the different colors of light that the lamp is producing.
Perfect. Ryan, is there anything at Intertek that would address that?
I would just say, I guess, if you want the different data and how important it is to you, if they are tunable sources, all of the data and the energy at each wavelength can be different. And I would recommend probably doing as many as possible so that you can get that data and be accurate about what you're trying to grow and where, and the test or the mounting height, I guess. I think it would be very beneficial to do all of them.
Okay, perfect, thanks. All right, we're getting close to the end here. We have 5 minutes remaining. I would like to make one note, one announcement. Actually, Ryan mentioned a little bit, just briefly during his presentation. The GLASE Consortium will host our first meeting on November 5th in Ithaca at Cornell University. The event name would be a guideline for new controlled environmental agriculture, energy efficient technology adoption. So we are bringing together New York and the Northeast CEA growers with utility companies, financial sources, financial loans, USDA representatives, and energy audit companies to provide the growers all the latest technologies and all the latest opportunities available to adopt new energy efficient technologies. We know here LED lighting systems are more efficient. They have several applications, a big potential into this field, but we all know that it is still cost intensive. It is more expensive than the traditional high pressure sodium light. So we're going to be hosting this event to show all the capabilities that we can offer and how can you acquire, right? Best ways to acquire these technologies. There are several programs out there from utility companies, rebate programs, financial companies that can make this technology accessible today. And then you can really unleash the power of having these energy efficient systems in your greenhouse. So I'd like to invite everybody. We will be announcing publicly the event by the end of the next week. So we're going to publicly announce, but for people here on the webinar, I'm giving this initial heads up. We do have about 5 more minutes. We can take one more question that came in, and after that question, I would consider the webinar done. So let me go and read the question. Will there be a general database for horticultural lights, such as those that exist for general lighting fixtures? Wow, good question. Ryan, do you know anything that is done by the regulatory agencies on that?
Don't quote me on this, but I do believe that if you're talking about an entity such as DLC, they will be having a database for horticultural lights. To be sure about that, I would email someone over there, info@designlights.org, and they can answer your question.
Excellent, excellent. AJ, do you know anything about that topic?
Yeah, I think I agree with Ryan that the DLC has the intention of providing a database. So after commercial companies have their lights tested at certified laboratories like Intertek, that information will be made available and will be accessible by everybody. For the lamps that we test, we typically have an agreement with the manufacturer that they will get the information, and we would have to go on a case-by-case basis if people wanted to look at data that we generated from individual manufacturers and individual lamps. So if people have specific questions about specific lamps that they think we have tested, please have them reach out to us and we can discuss with them on a case-by-case basis whether and how we can provide that information to them.
Fantastic. Well, thanks, AJ. I would like to thank AJ. Thanks, Ryan, for hosting the webinar. It was a great presentation. Also, would like to thank everybody who logged in today and stick with us until the end. I really appreciate that. I hope you enjoyed the webinar, and I look forward to see you here on the next session. And if you are available November 5th, come to Ithaca, come join us during the meeting. We're going to have a very good lineup and try to bring all these benefits to CEA growers and lighting manufacturers. With that, I would like to thank everybody one more time and say goodbye. Have a good day. Thanks, everybody.